Academy, Department of Mathematics and Computer Engineering also. And the title of his talk is about the interaction of serial Wi-Fi UAV communication protocols and the countermeasures. Drones. Yeah? Yes.
Thank you, Professor. I trust we can move the camera and I
Yes.
can be standing, right? Excuse me, but it is a habit for me to stand during a presentation. My name is Philippos Papalos, and I am currently second lieutenant. I have successfully finished the Hellenic Army Academy. I'm doing my master's. My master in cryptography and forensics and security. First of all, before I start, I'd like to thank Dr. Nicolas Bice and Dr. Nicolas Lucas for their very, very important and helpful guidance. Without them, this wouldn't have been possible. The title is Interception of Wi-Fi Civilian UAVs, and we're gonna talk about the protocols they use, and we're gonna find the solution in how we can actually secure our facilities against certain UAVs. Now the contents is the reasoning. We're gonna explain the protocols. How can we control a drone via a computer? How can we use monitor mode? We're gonna get the detail. The authentication attack, taking control, and after that we're gonna automate the process and place it in a microcomputer so that we can actually use something. We have a program that works. We do have a program that works, maybe the remote doesn't work that well. Now, UDP and TCP. UDP and TCP are the two protocols that are used in question when we talk about drone communication. They are used in conjunction to one another sometimes. They're also widely used on the internet, with TCP being way more used. UDP is used mostly in gaming or video streaming. And they don't differ by the type of information they send, but by the way they send it. We will see next slide. This is a basic example of TCP. TCP protocol, transmission control protocol, requires a verification. It's a very important step. We send the packet, the receiver sends something back saying, hey, I received that packet, you can go ahead and send the next packet, which can sound simple, but it's actually very complicated and hides a lot of complexity. I think that the go-to volumes for TCP communication are around 2,600 pages in total. So it's very complicated and complex stuff. Next slide, please. Thank you. Now we're going to talk about UDP, which is not that sophisticated. UDP is just basically sending packets. I open a connection, you open a connection, we connect our sockets, and via the UDP protocol, I just storm you with information. Whether you receive it or not, I don't really care, I'll just send it to you. Here we have two examples. On the left side, we have a not stable connection. We have a connection that some packages are being lost, therefore there are some rough edges, etc. On the right side, it is obvious that the connection is way more stable, and there are less or maybe no packet loss at all. Next slide, please. Now, the way the drone works is basically The idea is the same for different manufacturers. What changes is the details, right? So, for example, we have DJI drones. To communicate with the DJI drone, you must, the DJI drone has this IP, and this port is open. For pilot drones, they have a different IP and a different port, but the idea is the same. You open, you use a socket, you open a socket using those infos, and you stream the data. The idea remains the same. Next slide, please. Now we're going to use the SDK of DJI drones for this work. What is SDK? SDK is a software development kit. It's being made by the manufacturer, and it allows us to program a drone, sending it commands via programming language, Python in this case. You can see we send the command, the drone responds, okay. We send takeoff, it responds, okay, it takes off, and so on and so forth. Next slide, please. Now, let's go into the more complex stuff that have to do with finding and attacking. First of all, we need to scan. To scan, we're going to use a monitor mode. Now, monitor mode is basically a scan of all local Wi-Fi signals. And it has additional information we're going to see in the next slide. But it is very crucial to decide on the correct antenna to use for two reasons. First of all, because it's going to work a lot, so we need something that has decent quality. And second, because due to the security risks, manufacturers have actually stopped supporting monitor mode in the latest antennas. So, for example, in the current work, we use this antenna. It's from 2011, 2012. It is the second version of this antenna. The first and second version have monitor mode. Third version is disabled by the manufacturer, so we cannot use them to scan. Next slide, please. To scan, we will, first of all, this program runs on Linux via Python, right? To scan it, we need to download a packet named AirCrack, and it has a lot of Wi-Fi tools. We can see here that the mode is managed. Managed is basically what we use for everyday browsing. We need to change it to monitor mode, which we do running the command stated. Next slide, please. And we are greeted with this interface. This interface is basically a scan. It is the results of the monitor mode. And what we see is the MAC address, the power is how close is the access point, the client connected to its access point, if there is a ciphering question, if there's a password, many different stuff. And we can actually continue to scan. I can scan a certain access point and see who is connected to said access point. Next slide, please. Now we will deauthenticate the attack. We need to attack the connection between the person controlling the drone and the drone. So to attack the connection, we're going to use a weakness of the Wi-Fi protocol named the authentication attack. We're going to explain in the next slide, please, which is way helpful. So basically, there is a connected user, there's a Wi-Fi access point, and then there's the internet. Where Wi-Fi access point, you can think of a drone, for example. The hacker sends a packet to the access point, and it says, "Hello, access point, drone, whatever you are. I am the connected user. Yeah, it's me, definitely. And I want to disconnect. I want you to disconnect me." So the access point is going to say, okay, since you want to disconnect and you are the guy that's connected, I'm going to disconnect you. So we break the connection. That's how the authentication works in nutshell. Now, to launch the authentication attack, again, we're going to go in Linux. We're going to download the AirCrack program toolkit and run this command. We need to specify the MAC of the access point of the drone and the MAC of the client who is connected. And lastly, the interface, the antenna, which we're going to use to send packets. Next slide, please. Now, we need to prepare the program that we're going to do. It is basically a Python program which runs in a Linux environment. We take advantage, of course, of the DJI SDK because Why create something when it already exists and we can use it? Next please. Now, I know we don't like seeing code because it can get very confusing and doesn't, so I'm not going to go into too much detail, but it's actually quite simple. We run a scan and we get the results in comma separated values. This is what we saw when we saw the monitor mode results in a file, in a text file. We go inside this text file and we search, next slide please, for certain MACs. MAC is basically the ID of any device that connects to something, whatever that is. And believe it or not, MACs are subject to copyright, meaning that DJI is the main drone manufacturer. It holds about 77% of market share in drones. Has certain MACs that it can use. And what we do is we search for those MACs. We say, I want to go into the list of MACs in the file and see if there exist MACs of a certain type. If we find certain type MACs, that means that, hey, that is from DJI, which is presumably the drone. The next slide, please. So then we're going, since we have found the MAC, we're going to find the connected user. Next slide, please. So we find the connected user by doing a new scan of the drone with monitor mode and all that, and we find the MAC that is not the MAC of the drone, therefore it has to be the MAC of the user who's connected to it. And we save it in a file. Why do we save it in a file? Because if I control a drone with my phone, that means that 10 days later, a security agent can come to me and say, hey, you controlled a drone that was used in surveillance in that facility. Therefore, you are the person who controlled that drone. So we can have an idea of who attacked us, and we can search and we can push charges. Next slide, please. Now, we are basically forcing our wireless card to deauthenticate a connection and we are going to deauthenticate the connection by launching a 20-packet attack. This number 20 here means that we're going to send 20 packets. Next slide, please. Now, I'm not going to explain much of this because it is kind of been resolved. It has to do with the quirks of a small device. We actually ran this program and we have written code on it in a Raspberry Pi, which is this thing. It's very small, very efficient. It's, of course, not that powerful, and it has many quirks. One quirk has to do with connecting to the internet. We need to specify, we need to write certain stuff, certain MACs and stuff, and then reset some work. It's very complicated. Don't look into it because we kind of found a solution to it. Next slide, please. And then we need to specify what we want our drone to do. So we want it to connect, I want it to land it, I want to take off. So after we establish a connection with the drone, since the connected user has been disconnected, then we can connect to the drone and we can control it. And all that happens automatically by just plugging a Raspberry Pi into a power bank, for example. And there is a video on that, but first I'd like to say the idea is that there is a legal gap on it, and that legal gap has to do with what can I do if I see a drone flying above my facility. I cannot throw stones at it, it's illegal. If it's a military facility, the military can't just shoot bullets at it, it's illegal. So I must find a way to make that drone land or make it not work whilst not damaging it permanently, because that's legal. That is illegal. Now, the latest version is a little bit more complicated. If somebody is into Python and all that, he can come and we can talk about it, but it has to do with changing the scan into being constant, into our device can work 24 hours. It funnels the results into a list, And if that list has max, meaning that there are drones, it attacks its max separately. Effectively, we can disable swarms of drones, right? Next slide, please.
Crash or Viet?
Now this is a video of the microcomputer working. Above we can see the microcomputer display and the current steps. And below is a very poor trial for me to try and fly drone inside my house. And because I did a very bad job, I've actually blurred the screen. So we can only see that there is an established connection. So the microcomputer currently is booting, it has booted, it is enabled monitoring mode. It takes a little bit of time because it has to kill certain processes and the microcomputer is slow. So after that, after it manages to start, now take in mind that I'm going to start it only one time, right? So this delay of 10 seconds will not happen. We are scanning for drones we're scanning for 10 seconds, intervals of 10 seconds. After we have finished scanning, we actually scan to find the connected user. So we have scanned and we have found the connected user, we have found his MAC, and now we are sending the authentication packets. The image below freezes, the connection is lost, and the user has disconnected from the drone. After the authentication attack has finished, we have a gap where the drone is connected, no one's connected to the drone, we connect to the drone, and we command it to land. So that's basically the idea of the program. Next slide, please. Now, I would like to thank you for your time and your attention. There are certain improvements that have already been made since it is an ongoing project. We saw the attacking swarms using a loop. The code has been sorted down drastically, and we have managed to overcome some weird Raspberry Pi issues, making it more reliable, because sometimes stuff just doesn't want to work in such devices. Now there are some improvements we are aiming to make. We want to support more drones other than DJI drones. We want to add a variety of Macs and software developer kits so as to target more drones. And we want to transfer the whole program into either Python only or Linux only ecosystem so that we don't need to bother ourselves with having Linux work with Python and so on and so forth. I'd like to thank you all. I'd like to thank Dr. Bardis. I'd like to thank Dr. Nicolas Lucas for their immense help. If there are any questions, I'll be happy to answer them to the best of my ability.
Thank you. Thank you very much.
Yes, please.
I would like to ask, once you get control over the drone, would it be possible for you, for legality reasons, to mimic a response, a feedback to the actual user of the drone, so that the user gets informed that his connection, his flight plan has been suspended for security reasons or for whatever reasons by some legal service, and he might get a message back that he should refer to some.
So I don't know if the question was heard, but the idea is that if I understand the question, is that there can be a warning system for a person, because he may not be just doing reconnaissance, he may be just be skimming around, not knowing that his drone is getting attacked.
Yes.
Well, that has to do a lot with the way the drone is constructed. I don't know if we can feed video. Probably we can. We need to study more into the ports and the way that the drone communicates. But a temporary solution that a programmer could make is to make it fly, instead of flying forward, make it fly backwards. Therefore, it creates a barrier that cannot be trespassed, right? So it kind of works in the same way, but not exactly, right?
But in every case, the drone, after it has been after the program has taken to roll over it, it will be driven to a safe place, to a safe landing. So
Yes, it will be commanded to land safely. Also, one more remark. In the Wi-Fi protocol, we are counting Wi-Fi interfaces. One interface can be used at a time. Since a drone has only one Wi-Fi interface, because only one person can control said drone, we cannot access the connection without kicking the other guy from the connection. That's why we are deauthenticated. We deauthenticate the connection. Else we would have just connected to the drone without problems, right? But it's impossible to have one Wi-Fi interface communicate with two different clients.
Professor Lupos, please.
Yes, please.
It just seems that you demonstrated that, okay, you're the good guy. You're trying to protect from illegal surveillance and so on. But if it is so easy for you to get into the drone and make it land, what will prevent the bad guy to intervene when you're trying to land the drone and kick you out and do something else with the drone?
If you look into the paper that is written for this presentation, we take a more sophisticated look into countermeasures of deauthentication attacks. And truth be told is that there aren't really any available, right? So what the other guy can do is have a cipher in the connection. That means that I cannot connect the drone, but I can deauthenticate his connection. Therefore, I can make him disconnect, effectively ruining his purpose.
There has been some work. I don't remember now I know the person who developed something similar, maybe not exactly similar, but he worked with the drones and demonstrated that indeed you can make the drone fly slightly off the target, and if this is possible, you probably can do many other things, but he also came up with what are the sensible defenses that you can deploy on the drone, so that if somebody tries to authenticate or do something else,
Cisco
it's not going to be so easy.
Yes, Professor. Cisco has currently is on the works of doing a cipher of the deauthentication packets. WPA3, you know the cipher, we use WPA2 mostly. WPA3 will come and provide a cipher, not for enterprise use only, I assume, and provide a cipher for the authentication connection, for the authenticating Wi-Fi connection. However, on most drones, because they're not that sophisticated, a person that wants to do reconnaissance into a military facility, for example, isn't going to buy a $5,000 drone, I assume.
Well, it depends on the purpose.
Yeah, of course. But here's a gap on the security level. Since we can find this gap on security level, that's why, and we have the next protocol for security, and also it has a gap in security level, the next one.
Just a couple of extra observations. Again, I may be talking completely off the point that you're trying to make here, but we had a project a couple of years ago with some colleagues from Spain. They were talking about surveillance, but using a commercial AUV. And if I'm not mistaken, what they planned to use for the communication was not the Wi-Fi. They wanted to use LTE.
Yeah,
for
other protocols,
other reasons. And also, it was not straight activated ones or QVCC, but because there are real-time constraints usually when you call the drone, they used DDS, distributed data service. They try to get some guarantees that the latency, the round trip delays are within some bounds. They were talking about 2 seconds, which doesn't seem real time at all, but it is there. So there is plenty of interest in this area. And,
also in that channel, they have to make authentication between the control and the user of drone. So also there's other methods in this philosophy to make the duplication, to cut him and to take the control with you, and then you can do everything, or land it, or destroy it, or everything. But this is a big gap in security, and where everybody is working a lot of years on that. Anytime we find something good, they make it better. Attacks is always on this field.
Thank you. Yes, there is LTE, which is basically using a satellite for communication, but it's way out of the field of this work because of the scale. We try to bring the scale down to make it more understandable. If we bring the scale up, then it requires more research. It requires way bigger area of studies and expertise, right? So we're trying to limit it to make it a little bit more understandable. But yes, the satellite communication is way more complex and can be way easier to it's way easier to cipher. Certainly. Do we have any other questions?
Any questions? Okay, from here, thank you. Next presentation is by Ioannis Jordan.